The electrical system provides electrical power to many different systems, from some flight instruments to aircraft lights to flaps and landing gear. The electrical system powers them all. The electrical system is usually comprised of a 14-volt or 28-volt direct current or DC system, made up of some basic components. These consist of an alternator, a battery, switches, circuit breakers or fuses, relays, a voltage regulator, an ammeter or load meter, and the electrical wiring which connects it all. Let's study some of these components in more detail. Similar to a car, the alternator is driven by the engine through an alternator belt, which generates electricity for the entire system. The alternator is the primary means of powering the electrical system during normal operations with the engine running. Not only does the alternator provide power to the electrical system, it also charges the battery. The battery is mainly used to start the engine or to power the equipment while the engine is not running. In cold weather, the battery capacity can be severely reduced, so it's important that the pilot conserves battery power. The electrical system is protected either by circuit breakers or fuses. Most modern airplanes are equipped with circuit breakers instead of fuses because they are resettable. A circuit breaker pops when there is excessive voltage, which results in high heat in the electrical wire. Fuses are not the popular choice today. Although they work similar to a circuit breaker, once a fuse burns, it must be replaced, and that electrical circuit will not be complete until that fuse is fixed. Circuit breakers are usually grouped together in the cockpit by the bus they are located on. Not the bus that brings you to school, but an electrical bus. An electrical bus is like a power strip. You can plug multiple things into a strip, and if you turn that strip off, everything plugged into that strip will not be powered. In an electrical system, the same remains true. The components of an electrical system are usually divided into multiple buses. For example, there may be a main bus and an avionics bus. On the main bus, main equipment such as lights are powered, and on the avionics bus, most of the instruments and equipment to run those instruments are powered. While there may be one electrical bus or many, the entire electrical system needs to be powered safely in order to prevent a possible electrical fire. In order to do this, a voltage regulator and alternator control unit work to monitor and control the electric system. The voltage regulator will allow the alternator's generated power to charge the battery and power the system with an acceptable voltage by stabilizing the output of the alternator. Finally, the pilot can monitor the electrical system by either an ammeter or a load meter. An ammeter shows the performance of the electrical system. If the alternator is providing sufficient power to the electrical system and is charging the battery, then the ammeter will show a charge. If the alternator is not charging the battery, or the battery is being used because the alternator has failed, a negative indication can be seen on the ammeter. A zero indication simply means that it is neither charging nor discharging the battery. While an ammeter shows electrical performance of the alternator in relation to the battery, a load meter shows the load that is being placed on the alternator. So if the alternator's load is 40 amps, then the indication will show 40. If the load meter shows 0, then the alternator is either off or has failed. If the alternator fails in any electrical system, the battery will provide power, but not for very long. Depending on the airplane and if there are any backup batteries, an alternator failure may require a diversion from the planned flight.